became absolutely clear that we had hold of a global concept, the concept that anybody on the terrestrial earth, whether they're in a desert even or Salt Lake City, they're living in a basin system. We were river-inspired, river-generated to understand the system and to discover that we do live in river systems. Our effort is to help students learn the system they live in, how it works, how it's a living system, how it evolved, how it is a vital part connecting, and how it supports the life at our coast, which is in no way independent from how we treat our inland areas. And I'm not talking just about pollution, I'm talking about the need for enrichment.
The River Lab program is unique in the fact that it is an education program that was started from outside the education system and has been a collaboration between the school system and the part of the program with the volunteer guides on the outdoor study trips.
We take all of the children in the public and some of the private schools in Fairfield in grades 3 through 6, and we take them to the same part of the river and talk about something different each year.
At present, the way environmental studies is positioned in our educational system is deplorable. It is loosely put in so that any teacher at the elementary level can check off any one of something she may happen to be interested in. If we taught spelling and reading and writing and arithmetic the way we teach environmental studies, we would be kicked out the door. It wouldn't be stood for a minute. But we can get away at this point with teaching about the system we live in, the very thing that supports our life, more than any spelling, writing, reading, or arithmetic, by this absolutely irresponsible, haphazard approach.
There are not very many towns that have this kind of education from grades 3 through 6. It's a wonderful program, and every one of us in that guides for Mill River really respect Joyce Shaw so much for starting the program.
What really caused the committee to get started was a road to come right smack through here. And there was concern about the dam on the part of the engineer, and so I began sort of trying to find out why something that fit in so artistically with the whole environment here was slated for removal. And I began learning about watershed and the fact that there was so much water now increased coming into the river and that there was more pressure on this old structure. So I drew up the committee then in the summer of 1966. About 9 neighbors, caring people came together and met here, and we started thinking what to do to be able to save this a section from the town. Then the struggle began, even going up and talked to the EPA director in Boston about how we could help communities to manage better their areas in terms of their watershed structure, to which he gave the answer, stop educating children and start educating at the political level, which sent us home on I-95 in total silence, my vice president and me, as I kept saying to her, he's right, isn't he? And she would say, don't know. And we realized the River Lab program everybody loves. Okay, you're not going to get anywhere in helping people get environmentally enlightened if you don't go with what they like and stop beating on what they don't like. So for heaven's sakes, don't let go of what they like. So we went against what the EPA administrator had advised us to do, put all our efforts behind the River Lab program, and we finally realized the whole point was in teaching how valuable the floodplain was to the river. And I knew that by starting a program with the children, that you would be able to involve the parents.
I truly have always been impressed by both Mrs. Shaw's initiative in beginning this program based on some very special and personal understandings that she had come to about the worth of knowledge of the river system and how that might impact choices that a community made in land development and in how it managed its resources, and in her perseverance in bringing this to the school system, assembling a cadre of people who have very successfully delivered this program within the Fairfield Public Schools.
It's great to see volunteers, parents, people with passion go out in all kinds of weather throughout the year simply because they love what they're doing and they love helping the younger citizens appreciate what they have and how they can help preserve it.
The River Lab guides are really wonderful. You can tell, as a teacher, you can tell that they've been trained properly, and they know their material very, very well. And I'll tell you, as a resident of Fairfield, each time I go to the river, I learn something new from these wonderful guides. Their training, I believe, is what makes that really a wonderful experience for the children.
Back when I started, there were maybe 35 or 40 guides per year. And now we have 100 guides and sometimes a little more. So here are all these people, all these women and men and teachers, as well as parents and grandparents who are learning all the important fundamental things about earth structure and river structure and how rivers affect and create environments. And once they have been through guiding the whole program, not only do their kids learn a little something, we hope, but the guides who have to lead the study trips really have to learn a lot more.
They're all filter feeders. They all clean the, and I think there's some rib muscles out here too. They all clean the estuary, keep the water clean.
The rain comes down and it falls to the ground and it flows down the river to the sea. The great and mighty ocean waves to the sky as the clouds pass, filled with oceans and oceans, oceans of rain. Drip, drop, drip, drop, drip-a-drop-a, drip-a-drop-a, drip, drop.
Oh, the rain comes down and it falls to the ground and it flows down the river to the sea. Oh, the rain comes down and it falls to the ground and it flows down the river to the sea. Oh, the rain comes down and it falls to the ground and it flows down the sky to the sky. Oh, the rain comes down and it falls to the ground and it flows down the sky to the sky. Oh, the rain comes down and it falls to the ground and it flows down the river to the sea. Oh, the rain comes down and it falls to the ground and it flows down the sky to the sky. Oh, the rain comes down and it falls to the ground and it flows down the sky to the sky. Oh, the rain comes down and it falls to the ground and it flows down the sky to the sky. The rain comes down and it falls to the ground, flows down the sky to the sky.
They go in the spring on a floodplain trip, and they witness the reproduction of so many forms, everything from the birds, the swallows coming back, and the kingfisher and its whole life cycle story, the plants around them, to the plankton.
It's a step program so that each grade level builds on the other. And by the end of the 4 years of study, the children will have studied the river at various times of the year and various aspects of the river. There's the classroom part where the students study in the classroom, and then a very important part is the field trips to the Mill River itself. One of my favorite things about the 5th grade level is the spring trip when we take water samples to show the levels of plankton in the river water. And it's very exciting to watch the children use microscopes, and it's often the first occasion they have looked through a microscope, and to see this plankton in detail with their own eyes, and then to understand that this plankton provides a lot of food for fish in the river and for other organisms, and that's why it's so important.
When they do their 5th grade study, they're going to take water samples. They're going to see if there is an abundance of plankton, because the plankton is the base of the food chain in the water. And after examining it in the classroom, they will be able to conclude what areas of the river are essential for plankton to thrive. And they might be surprised at what they actually eventually conclude.
They take back water samples to the classroom, a fast and a slow sample. The fast sample comes from where the river is flowing quickly, and the slow sample from where the river is hardly flowing at all, and those are the backwater areas. And they examine the water samples under a microscope to identify the number of plankton that is in the water. And what they discover is that where a river is flowing quickly and where it looks pristine, because fast-flowing water often looks pristine, it may not be, but it will look it, that there is very little plankton life. And in the slow water samples where the river really looks and often is smelly and horrible and full of debris and decaying organisms, that's where you find a lot of plankton.
And of course, when they get back to the classroom, we know what they discover, where the plankton is, because plankton is not something that remains very much in a flowing area. And they learn the importance of the areas that we might aesthetically reject of a river system. And it's a major lesson in learning that a river system is a sum indeed of its parts, even those parts which might not attract us, that have their role very much in the whole ecology and the productivity of a river. And why is this important? Why do we care whether a river is productive? We care about it because if it isn't productive here, it's not going to enrich the estuary, and we're not going to have such a productive coastal system, which is so vitally important to us.
It was fun getting the samples of the water samples, and looking at the different life that there was in the microscopes. The slow water has more life than the fast water, and a lot of microscopic living things live in the water. More animals live in the slow water, and it's part of the food chain. The food chain helps us live. I didn't think there was that much life in the water. Well, it was tiny creatures, yeah.
I thought it was really neat. We'd see water fleas and copper pods. One of them gave birth, and we saw the little babies, and we saw a lot of other ones with that were pregnant. We got to see what was in the water and look up close. Next time I look at a river, I will know what is in it.
A lot of times in science curricula you talk about the solar system, which may be hundreds of billions of miles away, or you might talk about Greek mythology, which was thousands of years ago. But in this case, children are discovering what's right outside their back door. It's a hands-on educational experience. They actually learn about some things in class, but they don't have to wait for that special day or special field trip to see it. They can discover it on their walk home.
We live in a basin system, which is what we introduce at level 3. What does this mean? What are the parts of a basin system? The third grader learns that in River Lab. and how it's a living system. And we take a representative selection that all fits together in a web of life, as a basin web of life, so that they learn the parts of the system and the living system it supports, at least a representative scheme that a third grader can handle. Everything from algae up to a human being.
In the third grade, we want to introduce the kids to the river, and we want to get them involved in something that will really grab them.
Now we're going to make a model river basin. Who knows what a model is? What's a model, Jenny? It's a small copy. It might not have all the parts, but it's a small copy, and it gives you some idea of how it works. And we're going to have a model river up here.
They go out with buckets, and the guides for their class show them how to scoop out a riverbed with stones that are on the gravel pile, and then they fill their buckets, and at a signal, great big rainstorm, why they all dump their buckets into the riverbed that they've created.
1, 2, 3, flood.
And they can see how this flood of water will sort the different sizes of stones and the sand and the silt. And the guides, of course, have been trained to show them what is happening and what the results are and how this could create different kinds of habitats. And then they go on and see on the ground how there are different habitats there in the open space at Mill River.
The children give you the answers, and you can see the light bulbs going off and the children going, oh yeah, that's why that happens. They see how everything is connected, and that's what I think is wonderful about the program, and that's rewarding when I see the kids' eyes light up and when they get excited and they make the connection.
In the fourth grade, they get into basic geology, glaciation, and underground water systems, and the different ways that different societies have lived on the river, made use of the river, and affected the river.
We start with the Native Americans. They really didn't have much of an effect on the underground water system or the river basin itself. They really depended on the river basin for their lives. They would fish in the waters, they would use the woods in order to hunt, so they really didn't change the river basin at all. When the colonists came, there were some changes that were made. First off, colonists built a lot of homes. They also had horses and carriages, and so they would need a lot more roads that they would have to clear out. They cut down almost 90% of all the trees. If you cut down most of the trees around and you build in some roads that are very hard packed and put in some houses, you're not allowing as much water to get into the underground water system. Now, if it's not getting into the underground water system, it's probably going into the main body of the river, and there can be a little bit more flooding. We've had a big effect on the underground water system because we've built many more houses than the colonists. We have a lot of roads, and they're all paved. We don't have big gardens anymore, but we do have a lot of stores. They're big stores that do not allow water to get into the underground water system, and at the same time, every single one of them has a very big parking lot. And of course, no water is getting into the underground water system from that. Almost every single home in Fairfield or in any place is surrounded by grass. And you look at the grass and say, well, that's good. That's great for the river basin system. But actually, grass is what engineers in the town will call green pavement. After it rains for quite a bit of time, the grass petals kind of squish together and don't allow any more water to go into the underground water system. It just flows off into the gutters by the side of the road. Anytime we get a big rainstorm, the water level in the river itself is going to rise. And as soon as we have more water, we have the chance of having more flooding. Flooding is a normal thing for a river to do. Why does it happen now more than 100 years ago? Because we've had an effect on the underground water system, probably is the biggest effect. We're not allowing water to get into the underground water system. And if it goes into the main body of the river, we can expect flooding. Grade 5 is in two parts. We take them to an estuary. There are 3 estuaries in town that we use, and hopefully what we're showing them is the estuary is a very productive place.
Understanding a river basin structure and how it works isn't just important for your resources inland. It's important to understand how we can manage our coastal resources, which are so vital to us. They learn, therefore, that each river has to be enriching of its estuarine, which is the area where salt and fresh water mix just at the edge of the coastal area. Each river has to enrich its estuarine area, where so many of the coastal organisms are nurtured, about 3/4 of them, or else it depletes it. In other words, if you sterilized your river and had it running completely pure through the coastal area, it would take away more nutrients from the estuary and thereby deplete coastal productivity more than it would benefit it. They learn why an estuary is so productive. They learn of the zillions of each kind of thing that's produced there and how it is adapted to survive in this environment and why this environment is so productive of it.
And in the winter, in the 6th grade, why, they go out in the dead cold and they learn how the animal life in nature can survive in the winter in all its different forms of survival. And then the marvelous haven that the river is for larvae and different forms of insects that winter in that form in the water, because it keeps them from freezing, and how they survive in the river.
Now, I talked about having millions and millions of insects just in this basin right here. I mean, we could sit here for an hour and continue to pull off these insects.
A big one. It's moving.
It's marvelous to lift a rock in the middle of winter and see what is on the bottom of this rock. I mean, I was simply enthralled to start this course in the winter and go out there and see what is under a rock in the middle of the winter. It's incredible.
You've been here at other times of the year, haven't you? When were you here?
Spring one time.
Spring in the 5th grade? Fall? Late fall were the 4th grade? So if you were actually a naturalist, a scientist in charge of this area, you would need to come at all different times of year.
The first one I'm going to show you has a lot of
Algae on it.
Algae on it, and a lot of
flies.
And it has, yes, it has black flies, and it has a caddisfly larva. Very, very good. Do you see?
Wow, it's like they're all moving.
Yeah. Okay. Now the reason I wanted to show you this rock is because look, it's not all rock. See, there are parts of it that are just plain rock. But see, all this stuff is built. Do you see all this? Do you see all this? These are caddisfly cases.
It was fun. I learned a lot. I'm very interested in nature and stuff, so I liked it a lot. I learned a lot of stuff about animals and plants and water, and what they eat and what eats them, and about how water is affected by plants and animals, and how animals and plants are affected by water.
Well, I enjoyed the program. I learned a lot about the animals and plants that lived in the basin of the river and the estuary and the tributaries, and I learned how necessary it is to us and how it helps us and keeps us living as long as keeping things within it living.
If everybody was aware of all the things that our program tries to teach in the schools and teach to the public at large when we have a chance, we could avoid a lot of environmental problems. If only we knew all these things 50 years ago, or even more recently, we could have avoided so many problems that are costing us lots of money now.
It's the kind of program that students carry with them as they move into their adult lives and forms a very powerful background of information on which they can make decisions as they are adult citizens of this community.
So many decisions that we make today will have an effect in the future. We may not see it for 5, 10, maybe even 100 years, but they will have an effect. One of the things that we're hoping will happen is that as children grow up, they become adults, they live in a town. It could be Fairfield, it could be any other town anywhere in the world. Every place on earth is part of a river basin system. And hopefully these children, when they're adults, will learn how to make some wise choices so that we can continue to live and not affect the environment so that we can keep it going for future generations.
The lesson that I've learned from Mill River has been that it took one person's actions to really get it started. Don't wait for a committee, a school system, or something to necessarily have the great idea that can make a real difference. If you act locally, if you see something that can be done, and you put your time and your talents and your resources to work, you can make a difference.
Our whole operation exists because we recognize that we don't really see ourselves as part of a system that supports us. In order to see that, we have to start learning from a young age, what is that system? How does it work? How does it incorporate me and the other life forms around me? This system is something that's working all year round. It doesn't have a time of year when it ever fully goes to sleep to ensure this living web in which we are a part, and how we connect with it in all seasons, at all times, in all places where we live on the terrestrial earth.